of connect the dots. Can anyone tell me, examine all 6 trig ratios at the same time? What is equal to what? Do you see any patterns here? There has to be some sort of pattern because we're using the same triangle that even though the opposite and adjacent are different, we have the same numbers. So what are the patterns? Can anyone tell me? Brendan, what do you see here? Exactly. The tan 30 degrees is equal to tan 60 degrees. So we can write that here. Tan 30 degrees is equal to tan 60 degrees. Anything else? Any other patterns? Yep. Good. So my sine 30 degrees, sine and my cosine. I stopped too short. Sine and cosine. So sine of 30 degrees is equal to my cosine of 60 degrees, and the sine of 60 degrees is equal to the cosine of 30 degrees. And we can see that by connecting all of our dots, connecting all of our trig ratios. So that's another important characteristic of the special angles. So don't just ignore this. You gotta really keep this in mind. These are rules that you have to memorize because trigonometry is a new concept and you're going to be expected to know all of this information for your unit guide and your test. Okay, so now I'm going to show you what you're expected to do in the assignment. So for example, I don't want to do this triangle yet. So let's erase these ratios. Now, for your assignment, it's very important. You notice that these are all whole numbers. Sometimes you have radicals, sometimes you have fractions. I want to see you converting 1 over root 3 over 2 into decimals. Whenever there's trigonometry, I do not want to see decimals on your assignments or your tests. You'll get 0 marks on your test, nothing for your assignment. So make sure you want to keep it in whole number form, fraction form, or radical form. So in your assignment, you're going to be given questions like the following. Sine 30 degrees plus tan 30 degrees. So if you have something like that, sine 30 degrees plus tan 30 degrees. Well, I know that my sine of 30 degrees is 1/2, and tan of 30 degrees is 1 over root 3. Okay? So one way of solving this, you guys haven't learned about conjugates yet. That's a grade 11 concept. You could get part marks for leaving it like this, or you could write in a common denominator. So if I make a common denominator, put those two numbers together, so 2 root 3 is my common denominator. Well, I would have to multiply this denominator by root 3, so I'm going to multiply this numerator by root 3. 1 times root 3 is root 3. I have to multiply this denominator by 2 in order to get the common denominator, so I'm going to multiply the numerator by 2 as well. So my final answer, because we're not in grade 11 and we haven't got to that level yet, would be having a denominator of 2 root 3, and my numerators are root 3 plus 2. Can't go any further than that right now in grade 10. I want to show you an example when you're going to be expected to do some multiplication. So let's change this question up a little bit, and we're going to have sine 60 or let's say okay, I'm going to take the cosine of 30 degrees. Cosine of 30 degrees. And we're going to multiply that by sine 30. Yeah. What's wrong? Oh. I don't know how to get that out of here. Okay, let's continue. And then we're going to add, let's say, tan 45 to the mix. So questions can get very long in your unit guide, but number one step is to substitute what you know and not to use decimals. So cosine of 30 degrees, for example, that is root 3 over 2. Can someone tell me what sine 30 degrees is equal to? What is sine 30 degrees? Yep. 1 over 2. And what is tan 45 degrees equal to? Tan 45 degrees. 1? Okay. Plus the whole number 1. Okay. So at this time we don't have a radical in the denominator, which is much better. So I have root 3 times 1, which is root 3, over 2 times 2 is 4. So I have a fraction, root 3 over 4. How can I change 1 over 1 so that I have a common denominator that I can combine with the root 3 over 4? Brendan? Yes, I'm going to multiply both my numerator and my denominator by 4 to get 4 over 4. So my final answer, put everything over 4, and I have root 3 plus 4. Remember, the root 3 cannot be combined with anything but another radical 3. Does everyone understand that? So it's just applying the rules you have right now to the radicals whenever you have it. Okay, give me a second to get rid of that keyboard thingy. Actually, I think I need a tall person. Who's tall? Keith, come here. I need you to click that little red on the... Oh, actually, never mind, Keith. I can do it from my keyboard. What am I thinking? Thanks anyway. Okay, so we're going to do 2 more examples. What's wrong? You didn't copy. Okay, let's stop everything and let Chris copy. Not just Chris, other people too. Marvin has it? Okay. I gotta edit this seminar. Okay, so the next 2 problems are going to be quite challenging. I need you to really, really pay attention and draw the triangle meticulously. So let's first draw this triangle together. Okay, so don't miss out on any piece of information when you're drawing this, please. So this is actually 2 triangles stuck together. We have the large triangle, angle ADC, that's one right angle triangle, and we have the small right angle triangle BDC.